In this video, section 5.3, exponential equations. An exponential equation is an equation where the variable is an exponent. This is different from what we had earlier, where the variable was a constant. As an example, take a look at 10 to the x, and let's set it equal to 112. Now, as usual, our goal is to get x is equal to. That's what we want. But we have to find some way to get x out of this exponent. And to do it, we're going to use logarithms. Now, the log we're going to use will have the same base as this exponent. So we are going to take the common log of 10x, and then that will, and these guys cancel out, so we'll be left with just x. However, as usual, we have to do this to both sides of the equation. So we're going to have to take the common log of the right hand side as well. And we'll be left with x is equal to the log of 112. Notice how we started with an exponent, and we end with a log. And that's because they're inverses. Let's take a look at a more robust example. Our equation will be e to the 4x plus 7 is equal to 38. Now, there's nothing happening to this base. There's no multiplication or addition, so we're just going to jump straight to taking the log of both sides. The base here is e, so that's going to be the base of our exponent. Wah, wah. The base of the exponent is e, and that's going to be the base of our logarithm as well. So we're going to take the natural log, ln, of both sides of this equation. So it'll be the natural log of e to the 4x plus 7 is equal to the natural log of 38. These cancel. So our left-hand side simplifies to 4x plus 7. However, we can't really simplify the right-hand side. It's just the natural log of 38. But that's okay. We can still solve. We're going to subtract 7 from both sides. Then we're going to divide both sides by 4. And this isn't pretty, but it is our solution. And notice how all of these steps, our entire solution, was inverse reverse, with this little thought right here that to inverse this exponential, we needed to use a logarithm. Let's solve another equation, but I want even more going on than there was previously. So let's take a look at 2 times e to the x squared minus 6 plus 8 is equal to 15. And you know what? I think this guy qualifies. It's spicy. I want to look at the order of operations here. Parentheses, exponents, multiplication, addition. And remember, when we're doing inverse reverse, we work backwards. So we're getting rid of that 8 first, and then this 2, and then we're getting rid of the exponent. Once we do that, we'll be looking at x squared minus 6. So it's the 6, and then finally that exponent on the x. It's a lot. It is. But I think we can get to this point and get e to the x is equal to without too much trouble. I mean, we just subtract 8 from both sides. Then we're going to need to divide by 2. And we're done. It's now time to apply the natural log. Okay, these cancel, so our left-hand side becomes x squared minus 6, which is an expression that we can solve without too much fuss. And that's going to be equal to the natural log of 7/2. Alright, simple enough. We'll add 6 to both sides. And then we'll take the square root of both sides, remembering the plus or minus. That was a lot, but hey, look, we've got our solution. X equals. And whenever we're doing this, we've got to remember that plus or minus. We didn't need to use the quadratic formula. We could have, but we didn't need to because there was just a single x appearing. If we'd have had something like 2 to the x squared minus 3x plus 4, then we would need to use the quadratic formula. That'd probably be a 3-pepper problem. That's it for section 5.3. Thanks.